Hi everyone, my name is Mike Cook. I'm a senior lecturer at King's College London, and this is a talk I gave at the AIIDE conference in 2022. In fact, I gave the talk about half an hour ago, and now I'm recording this version for YouTube, so I'm still a bit full of coffee and energy. I've also just recovered from COVID, so I might still have a little bit of a cough. Hopefully that won't come through here. But this is a paper I wrote earlier this year about a new system of mine called Puck, an automated game designer, and it's the new system that I'm working on now as the bulk of my research. I'm still funded by the Royal Academy of Engineering, and their support over the last 4 years has been why the system was able to come into being. I've still got 12 months left of their funding to chase more fun extensions and keep moving this work forwards. So the last time I presented a paper at AIIDE, which is the conference that this paper's at, was 10 years ago when I was a PhD student. It was one of the first papers I ever wrote, and it was about a system I was building called Angelina. This was actually already the second version of the system, and it generated games about Guardian newspaper articles, and it made pulled down images and sound effects from the web and put them all together and designed a little platformer around them. And really, for the last 12 years, this is what I've been looking at. I've been looking at AI systems that can generate games and thinking about how best to do that, what the implications are of doing that, and how we can work with game designers and game developers to find out what they want from technology like this. And since getting the funding from the Royal Academy of Engineering 4 years ago to have this fellowship and this independence, which was really, really fortunate to get, I decided to take kind of almost like a little bit of a break from my work and begin to think kind of what it actually means to work in this area. And it's around then that I came up with this kind of phrase that I now use at the start of my papers to talk about what we do in this field. So I describe the field of automated game design as being about modeling, participating in, or supporting the game design process with AI. So what that means is that not all of us are building systems that generate games. Some of us are building systems that assist in design tasks or model like theories of game design, for example. So there's a lot of different work going on in the area. But for me, the question I want to answer is how we can build AI systems that can design games. And so, a few years ago, I sat down to think about what that actually means. Like, it's kind of a weird thing to do. Often when I explain my work to other people, I think, why am I doing this? Why do I want to build an AI that can make games? And actually this year I published a paper at the IEEE conference on games. It was a vision paper called Optimists at Heart. And it was about the motivations of game AI researchers. And if you get a chance to read that paper, I'd love to hear what your thoughts are on it. So what are some of the reasons we give, or that we might give, for building AI that can design games? Well, one that is very common that comes up is to help other people design games. So work, for example, by Tamara Duplantis et al. For generating Game Boy GB Studio games, so Game Boy style RPGs. These tools are here to help other people engage in the game design process, whether they are expert game designers or maybe building a game for the first time. And this is a very common motivation for work in this area, and I think it's a really great one. Another one that we might think about is the idea that an AI should be able to generate really good games. And this is something we see in other areas of creative machine learning, for example, and creative AI. So something like Stable Diffusion or DALL-E 2 is trying to generate good visual art. It's trying to generate high quality outputs. And normally the reason why we're impressed by a new system is that it generates even better output than the previous one. So it makes sense that if we're trying to build an AI to generate games, then we probably want those games to be good, maybe, right? And if we don't want them to be good, then we probably want it to work quickly at the very least. And actually, when I used to speak to journalists or game developers or the general public about my previous system, Angelina, people would often ask, well, how fast does it make games? Like, how long does it take? And could you imagine it happening even faster? And actually, what we see with creative machine learning now is that there's a real push to get these systems to generate art instantly. And Stable Diffusion is the latest to do that. So the idea that we can get to real-time generation of creative artifacts, that's a goal. But as I was sitting down to plan Puck, and this was a few years ago, so this was kind of before a lot of these creative AI systems really hit the mainstream, I realized that I didn't actually care about either of these things. I didn't really care if I generated good games. There's loads of good games in the world already. I have too many games. I don't get enough time to play them. And I didn't really care how fast it generated those games either. But quality and speed are the two most common ways that we evaluate scientific work in a field like creative AI. They're very, very common things to do when you're building a system and you want to evaluate it, but they just didn't really make sense to me anymore. They didn't really seem to be the most important things about the systems I was building. And in 2020, I gave a talk at COG. It was a tutorial about automated game design. And as part of that tutorial, I talked about the desire to enter what I called the infinite Rembrandt zone, where you have this system that is outputting very, very high quality, masterpiece quality level works with zero cost, zero resources, zero time. Like that feels like the goal that we are pushing towards often. It's the goal that people want to imagine is possible. But often this doesn't seem to actually be beneficial. It doesn't seem to be something that people would want or that would be useful. It's something that we strive towards because it feels like progress, but it doesn't seem to be kind of the best way to build systems like this, even though that does seem to be where a lot of creative AI is heading towards now. So if we're not going to build systems that look like this, if we're not going to build systems that are aiming to get to the infinite Rembrandt area, then what are we building systems to do? Well, this talk is about the system that I'm building called Puck. It's a pretty short talk. I'm taking it a bit slower now for YouTube than I did at the conference, but if you want the gory details about the system, I recommend the paper. But one of the things I wanted to talk to you about today is the kind of model I've tried to build Puck in the name of, which is to build systems that are kind of like Pokemon. That's how I think about it. I call it the Pokemon model for AI. And what do I mean by that? Well, I want to build systems that have the same qualities that these cuddly little creatures have. So Pokemon are friendly, they're cute, people build very personal connections with them. And I think that's a really cool thing for technology to do. Technology nowadays is less personal than it's ever been. We talk about personalization and we talk about recommendation and we think about like the algorithm curating our feeds on TikTok or Twitter to our tastes. But really it's not doing any of those things. What it's trying to do, what something like Netflix does, for example, is to find the nearest bucket that it has that it thinks it can lure you into falling into and convincing yourself that this is what you want to see. YouTube recommendations are another great example of this. YouTube is terrible at really understanding what a recommendation is. It can make you watch videos, but that's not the same thing. And when I was working on Puck, I was thinking a lot about the software I used in the late 90s and early noughties when I was kind of growing up with technology. And often I think of Puck as closer to something like a desktop pet. And I think about how that software felt like software that I understood and that I had ownership over and that I had control over in many cases as well. And that doesn't always mean that we want control over creative AI systems, but there's a difference between having a creative AI be playful with you and having a creative AI be something that you don't understand and can't control and don't have a relationship with. The other thing about Pokemon is that although in like the anime and the video games, which I don't actually have a huge amount of experience with, but my students are very good at teaching me about, the Pokemon do exciting things for the main character, but for everyone else, they're just a part of their everyday life. You know, there's Pokemon here helping this lady knit some things, and that's kind of something that's missing from a lot of technology. And actually, one of the great reviews that I got for this paper was to point me towards something called the slow technology movement, which has been going on for about 2 decades. And it is the study of AI and technological systems which are not aimed at efficiency. They're aimed at our everyday lives and interactions and ways of being and existing, and thinking about how technology can integrate itself into our life over a longer period of time. And this is very similar to the kinds of philosophy that I wanted to build into Puck. The idea that this system was not about optimization or efficiency, but it was just about being a part of our life. And Pokemon are tiny, they're cheap. They're accessible. They don't need much food to keep going. And that is also really important for technology. Obviously, creative machine learning, one of the things that people often talk about is the environmental impact. But even if we assume that's going away and that everything's going to become super efficient, technology is not something that we can rely on forever. We can't assume that everyone has access to the cutting edge, and we shouldn't assume that the cutting edge is always going to be advancing. We should be looking at ways that we can build technology that can run on light hardware, not a load of fancy stuff. And Puck is built to run on kind of anything. If you put it on a slower machine, it just runs slower. And if you put it on a fast machine, it doesn't necessarily run that much faster. It just is what it is, and that's fine, because I'm not interested in building something that works really fast. I'm happy for it to take weeks or years to make a game. And Pokemon are kind of well-behaved, and by that I don't mean they're literally well-behaved, but what I mean is that you kind of know what you're going to get with a lot of them. And I think that's really important for technology as well. The idea that people feel like they have an understanding of the thing that's in front of them. When we think about technology these days, that's not always the case. So when you talk to Alexa, you don't really know where this data is coming from or where this voice is coming from, and it can change all the time without you realizing, because someone controls these servers that are very far away and they're constantly pushing updates, and you don't really have a sense of ownership or involvement in it at all. So the way that Puck is built is it is completely open. You can hack it and open it up and look at all of its configuration files, and you can tell it when to stop and when to start. It doesn't track any data from you. It's not trying to learn. There is no server somewhere where all of the game designs are being sent. Your version of Puck is just your version of Puck, and if you never upload anything that it makes or share it with anyone, then no one will ever see it, and that's fine. It's yours. So, as I said, this isn't going to go into like loads of technical details, but I did want to take you on a little tour of some of Puck's features. So this is what Puck looks like when it's running in what we call design mode, when it's designing games. And on the left-hand side here, you can see the board. So at the moment, Puck makes these kind of simple mobile and puzzle games with loads of gems on grids. And you can watch Puck play games as it's designing them. So you're watching it work in real time. And on the right-hand side, you have descriptions of the games being played. This description's buggy. It's not accurately done. The game descriptions are a thing that we need to improve. But the point is that there's a lot of scope for communication. So Puck is trying to talk to the player, talk to the user, the audience, tell it what it's doing, and what the state of the current game is. And if Puck is left to its own devices, it will move between many different modes of operation, doing different things, designing games, expanding games, testing games, and we're obviously going to be adding to those features over time. So I'm going to have to take a drink before I cough. Puck is also an app. So my previous system, Angelina, was more of a research platform. It lived on my computer, and when I was running it, I couldn't really use the computer for anything else. But Puck is something that you can download with your own copy, and it has buttons on that you can press that do stuff. So you can ask for more information, or you can tell Puck to stop designing and go back to the main menu and choose some other features. One of those other features is to see all of its games, and you can click on any of the games that it's designed and play it against Puck, or play it yourself against another human, or watch Puck play itself if you want to do that. And something that Puck does is you can see the rating. So you can see Puck's estimation of how good this game is compared to all of the other games that it's made. And you can also see information about what Puck's experience of the game has been so far. So you can see here that this game has been tested 4 times and it's scored above average. And you can see there's more buttons in the bottom right, things like favoriting games that you want to come back to. You can rename games, you can leave notes for yourself. And we'll be expanding this later on as well, because Puck is going to be able to change the ordering of these games itself. So we need ways for players to be able to keep track of things that they're interested in. One of the ways that Puck operates is inside it has something called a finite state machine. So if you don't know what that is, if you're not an AI researcher, it's basically just a way of switching between different modes or different ways of doing things using like very carefully defined rules. So for example, if we're making new games, if Puck is coming up with new ideas for games, there might be a rule that says, well, you've been doing this for half an hour now, so now it's time to go and do something else. And then it will leave this mood and it will move into a different mood where maybe it plays games that it's already seen before, or it just goes to sleep for a bit. So this finite state machine controls all of Puck's behavior, and our aim here is to have it so that Puck can change the qualities of this finite state machine. So what that might mean is that your Puck has a slightly different way of behaving to mine. So your Puck might get bored more quickly, and it might give up on making new games much sooner. Or it might be the opposite. It might be obsessed with making loads of new games, and it never actually expands the ideas that it comes up with, which is a bit like how I make games, unfortunately. One little technical detail that I did want to mention here, because I really like it, is that Puck remembers everything that it does. So in the previous version of Angelina that I built, which was the last version of the system, I began to experiment a little bit with what I called continuous automated game design. So this was the idea that the system would never stop working. It would always be doing something, and it would keep these little project files of games that it was working on. So with Puck, we extended this idea, and now Puck records everything it does. So any game that it plays, it records all of the rules, all of the times that it's tested it, and the exact parameters it used to test it. It even records what kinds of moves it made when it did the testing. It records everything the user has noted down about it, or the last day that it was tested, like the actual date and time. And this is really useful, not just immediately, like we're using it now for certain things, but I also tried to record as much data as possible for future work that I might want to do. So we're building up a database on my version of Puck, but also yours if you download it. So it's getting loads of data that we might use in the future for some other exciting thing. And this is quite an important feature because something like Angelina previously used what we call computational evolution, which is a very established AI technique. It's its own school, kind of separate to what we now call machine learning. And what would happen is if it saw a game that it thought wasn't very good, it would just stop playing it. It would throw it away and not consider it ever again. And that's fine. But Puck doesn't do that. Puck does still use an evolutionary structure to the way that it runs, but it doesn't throw anything away. It always remembers everything that it's done. And as it says at the bottom here, this is stored in text files. So you can go and open the file for any of these games and look at what it's recorded about it, look at its information. You can even edit it if you want. You can break Puck. It's perfectly possible to do that. That's part of the philosophy of keeping it open and hackable. And this was very much inspired by Nathan Sturtevant and his colleagues' work on what they call exhaustive procedural content generation. If you haven't looked that work up, it's some of my favorite research work ever, so you should definitely do it. Now, Puck doesn't actually exhaust its design space, but it will eventually if it works for long enough. So because we have some of those elements of exhaustive PCG in it, it's what I call partially exhaustive AGD. You can see a little example of a text file on the right here. One of the nice features of this, and this thing, like recording everything that the system does, has thrown up some interesting features. So first of all is these files represent it's almost like you've compressed all of the time Puck has spent working into like this crystal of data. And if you lose that data, it's kind of like you lost the work. It's kind of like Puck has lost its memory. And I have had to reset the system and wipe it a couple of times. And you're kind of losing that computation. It's like you never did that work, sort of. The other interesting thing is if you change anything about the system, you kind of invalidate Puck's memory. So if you change the way that the agents work when they play the game, or if you fix a bug, even if you fix a bug, what you essentially now are doing is you've changed the conditions under which these games are played. So potentially all of the data Puck has about how good a game was could be flawed. And there's some really interesting challenges in how you can repair these databases without having to chuck everything out and start again. So I have this system that Puck can use to repair people's data sets. We don't use it currently because A, it's very time consuming, and B, most of our users don't have very large databases. I'm the only one with a really large database, and so far I haven't pushed an update that's broken anything for anyone else. But in the future, it might be that Puck sort of assesses the impact of these changes and tries to repair its knowledge. But my favorite thing about the persistent memory is that the idea of a bad game is now a completely relative concept. So as I said, in the past, if Angelina saw a bad game, it would say this game is bad, and it would throw it away and never play it ever again. But Puck just notes down the fact that this game is not very good and records it and then moves on and does other things. And what that means is that 6 months later, a year later, 18 months later, if its notion of what a good game is changes, for example, maybe you teach it something, or maybe it learns from playing its own games, or maybe I just patch it so that it has a different opinion of things, it can revisit these games and reconsider them and change its evaluation, change its opinion about them, basically. And this happened during development. So games that were buried at position 1200 in a list of 1300 games that I hadn't even seen because Puck had put them so far down the list that I wasn't even looking at them. Suddenly I would change something about the way we evaluated games, and Puck would suddenly say, hang on, this game that I thought was terrible is actually kind of interesting now that I think about it again. And then it would shoot up to the top of its game list, it would get selected for more testing, and Puck would expand it and work on it. And that was really cool, and it also acts as a kind of anchor to tell stories about the system's creativity. Because Puck can then say, this thing which I thought wasn't very good, I got a surprise today and I was able to build all this stuff. And I really like that from a computational creativity perspective. So what's next? Well, partly what's next is that I have a lot of emails and meetings and supervisions and grants to write and lectures to give eventually. I'm very grateful for my permanent job, but it's definitely changed my relationship with my research, at least for the time being. But when I do get a chance to work on Puck, there's some things I want to do next. One is that I want to build a design interface. I've started work on this. So this will actually let you design games using the same language that Puck uses. And the advantage of that is that Puck can then play your games. It can learn from them. It can maybe give you feedback. And it begins to expand Puck's creative community to not just include itself, but it includes you and maybe anyone else that you want to include in as well. So I'm really excited about that. I also want to make sure that Puck can make different types of game. So we've built it so that it's very modular. You can just kind of pull out bits of the code and put in different bits, which means that we can hopefully next insert a roguelike module. Not like a big roguelike, I mean like a little small, like a roguelite, a little small grid with a man that walks around and pokes things with a sword, that kind of thing. And we really want to work on Puck's communication skills. So there's some great researchers at King's who work in NLP, among other things, and visualization. And I really want to work on Puck's ability to describe games, to communicate its intent to people, maybe even to talk to people about what its intentions are for the future. And speaking of the future, before I wrap this talk up, I wanted to leave you with a couple of thoughts that I've had. So over the last 3 years, I've been thinking a lot about what it means to research in this area and why I do it and what I want to do with the future. And in particular, watching all of these creative ML systems develop, not in games, but in fields adjacent to games, has been a really interesting it's been an interesting thing to witness while also thinking very deeply about your own work. The last few years have been very difficult for me, and that's been a lot of reflection and thinking about why I do this job, for example. And one of the questions that keeps occurring to me is, what is the function of these systems? Why are we trying to build AI that can generate things for us? Because on the face of it, there's no need to do that, right? We talked about helping other people design games earlier, but of course there are people that will help you design games. You can design games with your friends or your family or your co-workers, or you can go to free classes, or you can just make them on your own, right? That's what people used to do. Obviously, there are many use cases where AI can support people, but these questions are still valuable to ask. They don't have obvious answers, in my opinion. And I've been thinking a lot about what the end game is, right? Because when we talk about these creative AI systems, we imagine this utopian thing where everyone has free access to amazing artistic tools, which is great, and that may be what will happen. But it's important to think about what the logical endpoints are for these things. So if one day Puck did manage to completely exhaust its design space, what would that mean for Puck or for game design or for people that use Puck? Would it mean that Puck was useless now because it's generated every game and looked at it? I think there's too many questions even for this extended version to go into there, but I don't think there are obvious answers. And I don't think that the purpose of creative AI is simply to make the best thing, right? There's no, people aren't out there making games in game development studios because they're all searching for the best game design. We make games for loads of different reasons. We make games because we personally find it fun. We make games because we like seeing other people enjoy things, or communicating ideas to them, or exploring stuff, or making money, or there's loads of reasons why people make games. They're not just out there looking for the right answer. So I think there's something interesting about the difference between how people approach creativity and how AI researchers approach creative problems. And maybe the real optimization problem, the real global maxima, were just the AIs that we kind of built and experienced. And one of the things I realized while working on Puck is that building Puck is really interesting, and that's not something I can convey to anyone else, because very few people in the history of AI have built systems like this, and it would be weird to suggest everyone do this, but it's really interesting building something like this and thinking about game design. And that's one of the reasons why I want to build an AI that is a creative collaborator, because when I look at what building Puck was like, I feel like that's the kind of energy that the AI can give you. It's about thinking about your own experience of these things, not so much just kind of skipping to the end reward, which is not necessarily what all of these creative ML systems are doing. That's not, I know that people are using these systems for all kinds of things, but when we talk about the future, the rhetoric about these systems are often more focused on the output and the process. And lately I've been thinking a lot about this image here, which is the tech tree from Civilization 2. And I've been thinking about how if you want to discover explosives, you have to have at first discovered chemistry. And if you want to discover chemistry, you need to have discovered medicine. And if you want to discover medicine, you need to have discovered philosophy. So the only way to discover explosives in the world of Civilization 2 is at some point in the past to have discovered philosophy. And it's kind of funny when you put it that way, but actually this is the public understanding of how science works, I think, in most cases, for most people. It is this idea that there's a linear sequence of ideas, and when you come up with a new idea, it was kind of waiting there. It was inevitable, and it had to be done in order for you to progress to the next idea. And that's why when we talk about future technology, we sort of just tell people, well, this is the way it's going to be. Like, these AI systems can generate art, and art is dead, dude. Like, that was the quote from the person that won that art competition. Like, yeah, this is just what's happening next. Is we're building these systems, and this is the way of things, and this is what the future means, and you just need to accept it. And I've been describing these big systems as giant mechas, giant big stompy robots that are very expensive, and there's only one of them. And we don't really know how it works. You sort of just stand from a distance and watch it do its thing. And it causes maybe some collateral damage along the way. But it's still cool. Like, it's cool to watch it. But it's definitely one way of building AI systems. But to me, it's not the only way. And I think 2022 was the year where I realized that we were no longer having a debate about the future of creative AI. These big labs have won the PR war, and they are now dictating terms, unless people get bored of their stuff, of course. And that's sad. At first I was very sad about it, but I've now realized that, like, that's fine. And I can still do my work. Like, that's what I spent the last few years thinking about. Like, what do I want to do with my research? What do I want to do with this very special position I've been given, which is to be a publicly funded researcher? And what I've realized is that, okay, maybe we can't fight, million-dollar companies and their PR agencies. But one thing that we can do is just to provide an alternate vision of the future. And I think that's actually very, very powerful. Just teaching people that the world is not a tech tree, and that the future can be decided, that multiple endings are possible, and that your decision matters about what kind of future you want. And we can have a conversation like, well, maybe you'd like an AI that's like this. Maybe this is how you'd like creative AI to work. Maybe you'd rather have a future that works this different way. Now, I'm not saying Puck is the answer to any of these questions. I'm just saying that I've spent a lot of time working on it, and that's the thing I've ended up making. And that's the thing that made sense for me at the time. And I'm really proud of it, and I hope that you like it if you download it. It's kind of janky. It's kind of a bit broken. But I am very proud of it, and I hope to get more time to work on it in the future with wonderful collaborators, such as my PhD students. So these 5 people down here are students whose supervision I'm involved with. Some of them I'm directly supervising, some of them I'm just assisting on the supervision. But they're all amazing people, and if you enjoyed this talk, you will really love some of their work on creativity and AI in games. I really recommend you look them up. And I also want to shout out here Mads Johansson and Sarah Cardinale, which both of whom have written papers with me on Puck, doing different things with it. Sarah did some amazing music generation stuff, sonifying the games. Mass and I worked on some juiciness for Puck. So it's already being a platform that we can use for other things, which is really exciting too. So yeah, thanks very much for listening. I can't do a Q&A on a YouTube video, but I appreciate this very much. And I hope that wherever you are watching this video, you're feeling safe and happy. And if we ever get a chance to talk about this stuff in person, I always like to hear people's opinions about the work. But you can also leave a comment below, and I'll try and respond to that too. But yeah, thanks very much for listening, and I will see you at a future paper talk, hopefully. Bye.